Good afternoon, ladies and gentlemen. Please be silent and I have some instructions. Please keep your mobile phone silent or switch it off. Secondly, do not use flash photography. Thirdly, do not leave the hall before the lecture ends and enjoy the lecture. Uh, Good morning, good afternoon, ladies and gentlemen. Dr. Bala Bharadvaj is one of the most pioneering individuals in the Indian flight industry. He is the managing director of R&D, Research and Development of Boeing India Operations. Dr. Bharadvaj has had a distinguished career working in various aspects of the aerospace industry. Currently, he works as the managing director of Boeing Research and Technology India, based in Bangalore. Dr. Bharadvaj has worked on demonstrating supersonic laminar flow in flight on the NASA F-16 XL-2 research aircraft, designing a supersonic transport aircraft using multidisciplinary design optimization, integrating new technologies into the C-17 Globemaster 3 airlifter, leading teams to implement long-range technology plans for Boeing defense system, to name a few. Dr. Bharadvaj has been awarded with several honors. Moni First Award for the Best PhD Thesis from Sigma Psi Scientific Group, Team Excellence Award from NASA Langley Research Center, Group Achievement Award from NASA Headquarters, Quality Hero Award from the Boeing Long Beach, and Process Management Tool Model Award from Boeing Long Beach. He's the chairman of Aerospace Board, a pan-India organization of aerospace experts all over the country. I would like all of you to welcome Dr. Bharadvaj. Please join us. To negotiate to all distinguished guests.
I don't know that I deserve to be called a big pioneer in the aerospace industry in India. I just happen to work at the Boeing company. And because you work at the Boeing company, you automatically get certain benefits because Boeing is a pioneer in aerospace. So you get perks because you are connected with a pioneering company. Very glad to see so many of you here. It's too bad that we can't accommodate the rest of the people. There are 2-3 chairs, open seats here if somebody wants to come in. Because we are on individual seats, we can't squeeze in any more people. That's too bad. But I'm glad you're here. How much time do we have? An hour? Okay. So my plan is to spend about 45 minutes telling you a little bit about different aspects of aerospace. If there is a published agenda title, originally I said I'll talk about role of technology in aircraft design, and then I got an email saying don't make it too technical. Because I suspect there are many people here who are not aerospace engineers or working towards that kind of a program. And if you think about it, aerospace is not only about aerospace engineering degree holders. In the Boeing company, we have many more people with mechanical engineering degrees than with aerospace engineering degrees. I happen to be one who has an aerospace engineering degree, but you don't really need an aero degree in order to be working in the aerospace field. So I'll spend about 45 minutes giving you kind of an idea, more than design, or at least we will talk about design, but very, very high level, different kind of aspects than maybe what your professors will cover in class here if you took a design class. But then I'll also leave some time, hopefully we'll have 10-15 minutes to answer questions you might have. Okay? So that's the game plan. Let's see if I can wake up this computer. Okay, so we're going to talk about role of technology because this is the Indian Institute of Technology and you are all here for a Techfest. So clearly technology is something we should talk about. And then I also touch upon opportunities because many times when I give talks like this, people kind of say, well, all this, it's great that Boeing is doing this, maybe in the US or somewhere else in the world, how does it affect me? So actually it turns out there are many opportunities in India to get involved in aerospace type activities. So we will spend a little bit of time on that. So this is what our talk will be organized around, give you some background about Boeing, some background about Boeing India. We'll talk about mostly technologies from the point of view or the context of the 787 program. The Boeing 787 is the newest entry, new airplane that Boeing has introduced into the market. It has quite a few very interesting things about it revolving around the technology. So we'll talk about that and of course the opportunities to do things in India. So starting from the Boeing company, it's a fairly old company, has been around for 95 years now. It started in 1916, not very long after the first flight happened. If you remember, the first flight of the Wright brothers took place in 1903. So there are only 13 years. I say only because those were very crazy days in the aerospace business. Many people had a variety of ideas. It's kind of like what the IT industry went through not too long ago. People started companies, some flourished, some did not flourish. So 1915, 1916 is when the first Boeing airplane was made. In those days, it used to be made of wood and fiber, covered with some kind of a cloth and so forth. Very, very different looking airplane. Of course, now, in this day and age, we are the leading producer both in the military and commercial aircraft. So when you put those together, Boeing turns out to be the largest aerospace company. Now, today's Boeing actually is a conglomeration, something that was created by many companies coming together. In the industry parlance, we would say merger. If a big company, it's a small company, we call it an acquisition. But whichever way you want to look at it, each of these companies mentioned there, North American Aviation, McDonnell Douglas, Rockwell International, Hughes, Jeppesen, they are all very, very well-known names, very, very respected names in the aviation industry. Each of them has done some very phenomenal things while they were in individual companies. And of course Boeing also, and now they all have come together, or at least significant parts of those have come together to form what is the Boeing company today. So like it says at the bottom, history of Boeing is very, very similar to, or matches almost, the history of aviation, both in the commercial sector and on the military side. What do we do today? We obviously make commercial airlines. Hopefully you fly those when you go places. The so-called 7 series, we have 737, 747, we used to have a 57, which is no longer in production anymore. We do have a 767 that's in production, 777, which we refer to as a 777, and then the latest entry is a 787. So, these are the airplanes that we make. There are various, versions of these. The airplane is not a static thing. For example, if you think about the 747, the first flight of the 747 happened in 1969. Long before many of you were born. And it is still being made. It's not the same airplane. It has undergone many changes inside and outside. And the latest avatar of 747, it's called 747-8, came out earlier in 2011. And it is more efficient, has more carrying capacity, quieter and so forth compared to its earlier cousins. So airplanes tend to evolve. new technology keeps getting added. It's not like you make it once and keep making more and more copies of that. They always evolve based on what we perceive our customer is looking for. And our customer for the commercial airplanes is airline companies. Jet Airways, Indian Airlines, All Nippon Airways, American Airlines, various airlines around the world. So we kind of anticipate what the airlines are looking for. We also look at what kinds of technologies are coming in the pipeline, and then we decide to make changes to our aircraft. If you look at the other side, we do a lot of work. Again, it says design, assemble, and support. So design meaning we imagine what it might look like, put it together, design it. We actually manufacture and assemble. And the assemble is more important than the manufacture. If you look at airplanes, they actually consist of thousands of parts coming together. We don't make every one of those parts. In fact, we have 22,000 suppliers that make some piece of the aircraft and send it to us. They don't necessarily spend 22,000 pieces, but depending on the aircraft, they assemble it. Little parts become assembled as what we call sub-assemblies or fairly chunky parts. Those get assembled further, and finally, we assemble the total aircraft. And that's really what we are meaning by assemble. But it's harder than it sounds. It's not like everybody sends everything and some Lego set comes together. There are people in the company who know about every one of these little parts that is being made somewhere in the world. It may be made in Japan, maybe made somewhere in Europe, maybe made in India, and somebody is keeping track of all these, making sure that they all meet the necessary quality requirements, the tolerance requirements, and so forth. And that's a non-trivial job. We also design and assemble satellites and launch vehicles. This item here, integrate large-scale systems. The aircraft itself, whether it's a military aircraft or a commercial aircraft, is a fairly complex animal by itself. But then we also look at how this complex thing behaves, interacts with other complex things. For example, if you think about commercial airplanes, commercial airplane, you cannot say, okay, I have my own commercial airplane, I can do whatever I want. I mean, you cannot even take off until you get permission from somebody in the tower. And they are communicating with other aircraft, other things that are going on. So it really becomes a complicated system now. It's no longer that I have my own airplane, I can do whatever I want. This airplane has to operate within a much larger system. And that's what we mean by the large-scale system. We are operating within a system of various other things working together. Similar thing happens on the military side. We also do things along the lines of communication networks, and then what we call network-centric solutions, where there's a lot more usage of not just the aircraft, but usage of information. If you go look at, if any of you are students of history, especially military history, wars are not won based on the stuff that we have, the tanks or aircraft or ship and so forth. There are many situations where, a large army or a large, armada of ships is defeated by some smart guy who does something very simple but very effective. So strategy, information, what do I know about the enemy, those are the kinds of things that help to win wars. So in this day and age, we talk about network-centric. If you're flying a commercial airplane, you like to know where are other airplanes around me. Is it okay for me to climb up or climb down? Am I going to bump into somebody if I do a maneuver independently? It's kind of like driving a car, except now this is in 3D and everything is happening much faster. And if the other airplane honks at you, you can't hear it. So you have to have something equivalent, to be able to. The last, but one bullet is interesting. We also have what we call provide financing solutions. Each of these things that we sell have a pretty big ticket. price tag. So even though if you all, some enterprising people can say, hey, we like to start an airplane, an airline company, you can do that. But then you got to come up with quite a few billions of dollars to be able to invest into that. And even people like Mr. Malya and others who are struggling these days, they don't necessarily put their own money. They put part of their money, then they go get money from other places. So that's where the financing comes in. Okay? How do you get a bunch of people, a bunch of banks or other investors to put together enough money so that yes, I can buy 5 airplanes, and with these 5 airplanes I can start an airline service. So we do have, because we want to sell these things, we have assembled quite a few finance experts who know how to generate these huge amounts of money that can then be made available. And then the last thing we do, not that it's unimportant, it's really about the future. We develop what we call advanced systems and technology. Now, at the end of the day, Boeing is really a technology company. We are an engineering and technology company. Although we make products, our products are desired, are of interest to our customers because they do something unique. And the uniqueness of our products comes from engineering and technology that we put into it. So we are constantly thinking ahead about, okay, we have rolled out the 787. This 787 will be around in service for decades. So what else should we be doing? How should we be improving this aircraft? How should we be improving the other aircraft? I mentioned the 747, that the first flight of that was in 1969. The 737 actually flew even before that. And that aircraft, I think that flew in 67, if I remember right. And in 2017, which is a few years from now, we are planning to introduce what we call the 737 MAX, which is considerably improved version of the same airplane that got started roughly 50 years ago. So these airplanes tend to hang around for a long time, but even though they may look the same from outside, they are very, very different inside. So in very simple terms, this is how we are organized. We have about 150,000 employees, plus or minus, keeps changing. We have the commercial airplane division and the defense, space and security division. And then we have all these what we call corporate functions. I have highlighted a couple of them. Engineering, operations, and technology is a very, very important part of that for us in terms of the technology and the improvements of the product. And then the international I have highlighted because most of the things we do, Boeing is a very, very American company. But then when you look at who our customers are, who we sell our products to, and who do we work with, it's very international. So even though it's an American company, we have a lot of interaction with people and organizations around the world. So I'm going to try something here. It kind of worked before. Sounds funny standing there. I wanted to show you a little video of what Boeing is all about. Better than that last time. dream we do. But I'll tell you, there is a lot of hard work that happens between the dreaming and the doing. A lot of hard work, not only investment, not only in terms of money, but also in terms of the effort that goes into it. So it's not an easy transition from the dreaming and the doing. Okay, so if I continue. Okay. So just a little bit about what do we do in India. These are all great things about India that you hear in the press. India is is in a point in time in history where things are generally very upbeat. Back in 2010, the President of the United States, Mr. Obama, was here. Actually, he was in Mumbai for some meeting, then he went on to Delhi also. And he made the statement basically that says that India is no longer an emerging country, it's already an emerged country. And sounds good, looks like, okay, we can pat ourselves on the back. But it also means certain level of responsibility. You are no longer somebody who can say, oh, I'm just a poor country, please help me. If you are an emerged country, you've got to help yourself. And hopefully help some other people too, okay, who are less fortunate than you are. Now, part of that is represented in the other bullets that I put down there. The main thing I wanted to convey is that when you look at the Indian economy compared to what is happening around the world, actually India has a pretty strong position. Individuals within India may disagree that, oh, I'm not getting what I would like to have kind of thing. But if you look around the world, see what is happening to established countries like the US and European countries and so forth, India is actually much better positioned in terms of how things look as we go forward. And then similarly, in some sense representing the statement that Obama made, India is increasingly getting recognized as a world leader or a leader that should be given an important position in world affairs. So, whether you like it or not, sooner or later, India is going to be expected to show that responsibility as a big country. We have something like, India has almost 20% of the world's population. Size-wise, it's a pretty big country. Economically, it's becoming more and more important. So all those indicate that India will be expected from India in various spheres. And the good news is, most of you young people here, you are in India, happen to be born at a good time. Okay, I don't know if you believe in stars and so forth, but the stars are actually aligned quite nicely. Now, what that means to Boeing is that because the economy is getting more and more vibrant, more and more people are willing to travel, and of that population, more and more people would like to travel quicker. Go sitting on a train, it'll take me 2 days to get to Delhi. I don't want to do that. I want to jump on an airplane and get there in 2 hours if I can. So there is more of those kind of individuals, and basically Boeing, Airbus, and other entities, they make forecasts of what is the expected market. I mean, this is part of what we do as a business. We want to know, okay, are there people willing to buy airplanes? How many airplanes? Where are these people? So when you make those kinds of estimates over the next 20 years, something like 1,320 airplanes. Don't ask me how they get, is it 1,320 or 1,319? It gives you an idea. 1,300 airplanes, there's quite a number of airplanes over the next 20 years. And again, there's a distribution of, are they big ones, small ones, and so forth. So there are methods people have developed, the marketing groups in Boeing, Airbus, and so forth. And the numbers are very consistent. So there's a big market, even though, you find airlines today are struggling a little bit. That's probably a temporary phenomenon because sooner or later they will figure out how to get around that because more and more people want to fly. And we do have customers in India. SpiceJet, Jet Airways are our customers. Up above is a 737. This is a 777 aircraft. And then Air India also has some of our airplanes. And then there are orders for the 787. In fact, Air India should be getting there for 787 sometime soon. And the 787 is going to be kind of the star of our discussion today. It's made a lot of news in the aerospace industry over the last few years, and recently it has been recognized with many international awards for things that it has accomplished. Now, similarly, I mentioned India becoming emerged, responsibility and so forth. And one of the responsibilities when you are a large country sitting, where we are. India is sitting, if you look geographically, but you can kind of see that all this area here is the Indian Ocean, and India is very much, strategically located. And what that means is India also. Somebody said India lives in a tough neighborhood. We've got issues around with some of our neighbors. So what that means is, okay, I've got to make sure that I have military capability to defend myself, to project my strength, and so forth. So that is what this list comes from. And again, India has its own industry where certain products are being made, but then there are many other products that India would like to get. And this is a list, and again, we estimate, okay, again, this is not, our wishful thinking, it's based on, what is published by the Ministry of Defense and so forth. So there are opportunities, and by the way, Boeing has already entered into agreements on two very unique products. The one on the top is what we call a T8I. It's a maritime reconnaissance airplane. Basically, it's a 737 modified appropriately for use by the Indian Navy. So they'll be able to get on that airplane and then patrol the seas. Be able to see are there any threats, who is traveling in the sea, are those people friends or not friends, and stuff like that. This is a C-17 airplane. It's what we call a strategic airlift airplane. And what that means is it can carry a whole lot of stuff inside. When I say stuff, I'm talking about tanks, helicopters, people, all kinds of things. It even carried a whale at one point. I don't know if you guys know how big a whale is. It's about as big as this stage is here, and weighs a ton. Probably not a ton, but a few tons. And a whale had to be rescued somewhere and transported somewhere else, and the C-17 has been used for that. This is about 10-15 years ago now. So this is another aircraft that India has signed up with Boeing to deliver, and we think we will be contributing to some other military products down the line also. So we know that there is a commercial market, we know that there is a military market. So basically, Boeing is in India, has been in India since 2003. That's when we opened our office in Delhi. We have been working in India, or we've been in interactions with the aviation business in India since 1923. I have a chart up in our office in Bangalore which shows all the various things that happened. So in 1923 we had a de Havilland aircraft that actually landed in, I think it was in Kolkata or someplace. And de Havilland, by the way, now is part of Boeing. Okay, so so the relationship, interaction between Boeing and India goes a long time ago. But then we established, based on the new things, different things that are going on, we opened an office in Delhi in 2003, and we opened a center, a research and technology center in 2009 in Bangalore. So our goal is, when we look at, okay, so what's Boeing doing in India? We want to be establishing ourselves as a preferred partner and provider, in aerospace. And when we say provider, that means providing products. We believe we have very good products that are, relevant to India's needs. So we want to be a provider of products. And then a partner means, this day and age, aerospace in particular, but also many other businesses, they don't work like they used to. There used to be a time when some company had a product, they would come and sell it, and then somebody gives them gold or cash or cows or whatever. It was a barter at that point. Whereas today the expectation is that you work together, you develop things together. So that's kind of the way the world is moving to, and that's kind of what we need. So, like I mentioned, we set up the Research and Technology Center in 2009, and you can very broadly, this is the only chart I'm going to show you on that. It's just a very, very high-level summary. Our goals here are to develop technologies and solutions. It's not just technology. Technology is nice, but ultimately Boeing is not in the business to develop technology. We develop technology because we want to develop products. So ultimately we are looking at solutions. We do partner with academic institutions, research labs, as well as industry partners. We already do that. In fact, we already have partnerships with several IITs, including IIT Bombay. And then we also do several things by way of building what we call the aerospace ecosystem. Now, I'll tell you a little bit more. Aerospace is actually more of an industry. It's not, one department, like a university, you say, okay, you have aerospace department, you have civil engineering department, and so forth. But if you really think about it, aerospace, as we refer to it, is an industry that involves many, many people, many, many disciplines coming together. So when we talk about the ecosystem, it's about if India wants to develop aerospace capability, what does it take? You need people who know about the subject. You need, certain technologies. You need certain manufacturing facilities. You need airports. You need people who can run the airport. You need various things. Everything has to happen. You cannot say that I know all about this. I'm an expert in XYZ technology, and therefore now I'm going to start an aerospace company. You won't go very far. So it is one of those areas. It is difficult because of that, because many, many things have to come together. But by the same reasoning, because many things have to come together, aerospace industry, whether it's Europe or in the US, tends to be collaborative because I, as a Boeing person, may not know everything, or I may not have the best knowledge about everything. Somebody else might have better information, better capability in a particular area, and in which case, I would like to team up with that other individual or other company so that put together we can create something better than either one of us can do individually. So that's kind of the thought process around the whole idea of collaborating and working with other people. Now there are certain technologies that we work on. Again, our presence in India is relatively small compared to our global presence. So we work on things that which actually have the potential to make an impact. And again, like I said, we don't do technology work because we want to publish papers. I stopped publishing papers back in the early 90s. Doesn't mean I don't do technology work. I do a lot of technology work, but not work that I can publish. I don't think that the journals care too much about what I do anymore. We also look at developing people. Many of our projects, especially when we do that in universities, they involve grad students. So the students get exposed to what we are working on, those particular projects anyway. Similarly with research staff, and things that we do help to develop these skills. In some universities, some selected universities, we do have a scheme of scholarships. Again, we can't be doing everything everywhere, so with whatever resources we have, we try to make an impact. And then again, here's kind of the ecosystem related things. We have 2 consortia that we have set up. Only one is listed there. This is the other one. These are the 2 consortia we have. NCA is actually located in IIT Bombay. So I come here a lot to talk to our buddies in NCA. It's focused around manufacturing technologies. And this is the Aerospace Network Research Consortium based in Indian Institute of Science, and has to do more with the electrons running around inside and what you can do with them. Again, we work with many groups like I mentioned, and we do depending on the area, certain areas we do have the opportunity for people to develop technology and publish. If it is at a very early stage, if it gets closer to the product, of course, it won't be published. Okay, so now let's go to the 787 program. There are 2 versions of that airplane that have been kind of advertised, and there are probably other versions coming down the line. 787-8 is the first one that will be has already been delivered, will be given to Air India soon, and so forth. And Dash 9 is a slightly different airplane. The main difference that you see is in the range. Number of passengers is more or less the same. Passenger carrying capacity is slightly higher here, and the range is higher here. Now, what's so special about this airplane? Whenever a company like Boeing puts out an airplane, it takes a lot of investment. Lots of dollars with a B in front of them. And so we have to think about how to recover that money back. So the company is investing, borrowing, whatever, or taking out from its profits, whatever it does. And then we have to say, okay, who's going to buy this airplane? And when they buy this airplane, what compels them to buy? So basically, the 2 big things that it is going after, this airplane is going after, is reducing the operating cost for the airline. Remember again, the airline is our customer. You and I are customers for the airlines, but because we don't buy the airplane. We go to somebody and say, hey, if you have a 787, I'd like to fly your airplane, right? I would do that. I don't know about you, but I would certainly do that. So for them, reducing the operating cost is very, very important. They want to take X number of passengers, let's say from Mumbai to Delhi or Mumbai to London or wherever, and they would like to spend less fuel, and especially when you look at the cost of fuel, it keeps going up. So if I can get better, more efficient, I know that's certainly a good thing. And again, similarly, they would like lower maintenance costs. They would like to have a mixed fleet, meaning they have certain products. Usually, you will find that airlines tend to stick to a particular brand because it helps them, with how to manage their maintenance and so forth. And then at the same time, it offers them higher revenue opportunities. In terms of, for example, it has more space for cargo. It has the ability to offer a non-stop service. You can travel pretty much 8,000 nautical miles. You can go to the other side of the world. And recently, the 787 made a world record. It traveled from Seattle to Dhaka, which was like 10,000 something miles, and then it flew, stopped, refueled, and then took off and went back to Seattle. And that was, both those were new records for airplanes of that type. Again, flexible seating, passenger preference. I'll show you a little bit more about passenger preference. One big thing, one big change that has been introduced in this airplane is the cabin atmosphere in the airplane. I don't know if you knew this from before, but most of the current day airplanes, the cabin is maintained at the equivalent of 8,000 feet altitude. So the pressure is maintained at 8,000 feet. And as you go higher and higher in altitude, our bodies don't like it very much. If any of you has gone mountaineering, you will know that as you go higher and higher, the body starts complaining. It takes time to adjust to it. So this airplane has a cabin at an altitude of 6,000 feet. Now, it might not look like a big difference, but if you go look up standard atmospheric tables, you will find out what that means. Big difference because the pressure is a nonlinear function with altitude. So there's a huge difference in the pressure at 8,000 feet versus 6,000 feet, and that generally means more comfortable traveling conditions, and especially if you're going to travel for many hours, 8,000 miles takes you 15, 16 hours to cover. So if you're going to be sitting around the airplane, you would like to be more comfortable. This is indicating, how the fuel consumption is significantly better than what's available today. That was basically what we started out with. So the connection with technology is when a company like Boeing says, well, this is what we are going to target, we're going to get there, that means what? You have to do various things to make sure that this airplane is actually more fuel efficient to that extent. Now, this is a little bit about the interior of the airplane, more for the airline company. You can arrange it, many different ways. So when you fly the 787, you may see any of those configurations. Some of the passenger-friendly features. Again, is there new technology here? For example, the better lighting is new technology. The way you shape the cabin involves new technology. The windows, it's not so clear here. These windows are actually much bigger than the windows that you see in the airplanes today. That's involved new technology. In fact, it also says electronic window dimming. There are no shades to pull down. It's basically the windows are closed electronically. Okay, so the panel has devices inside that you can say, make it dark. So there are a lot of technology that one doesn't necessarily think through. Comfort-wise, sound quality is again a matter of how you shape the cabin and what goes inside the cabin. Temperature control, smoother ride involves a lot of new technology. Improved cabin humidity because of the lower altitude and because of the materials that we have chosen to use. Cleaner air, again because of what we call the environmental control system. And then the lower cabin altitude I mentioned before. So this is what you can look forward to. Again, these are concepts. Every airline will do the interiors per their requirement. You can see that shading of the window, that can be controlled electronically. It can be made completely dark or partially, depending on which one wants to do. Okay, so how do we accomplish these kinds of things? You accomplish better environmental performance. Everybody says go green. Whether people really do it or not, a lot of green paint is used these days everywhere. But what it means to us is reducing the carbon dioxide emissions, as well as what we call the NOx and carbon monoxide. Okay, these are things that are actually measured. There are rules and regulations set in place by regulatory agencies. So basically, that comes from using a better design for the airplane. So, those of you who understand the aerospace business, you need an engine basically because there is drag. So if you reduce drag, the engine required would be, or the thrust required from the engine would be less. So you can reduce the drag. That's the first thing you do. And the next question is, how do I produce this thrust? What is my specific fuel consumption? So, that part is provided by the engine companies, that part is provided by Boeing, and the combination is what is helping us in the design process, the technologies used, and so forth, to make it more fuel efficient. Noise is a very important thing in the airplane business. Everybody would like to have an airport very close to where they live, but nobody wants to hear these airplanes, going in and out. And there are very strict regulations for how much noise, these airplanes are allowed to make. I mean, those regulations have been progressively getting more and more stringent, more and more strict. So there are different ways that different technologies, different materials that are used to to make the noise less, both inside the airplane as well as outside the airplane. So if an airplane is flying by, what can they hear? If the airplane is taking off from an airport, how far does that noise propagate? So there are technologies involved in all those. And then similarly, life cycle improvements in terms of what do you do? How much unnecessary or unwanted stuff do you produce while you are manufacturing the airplane? How do you reduce your environmental footprint? People talk a lot about carbon footprint. If I have to create, a pen, how much of an impact does it make? I can do it very efficiently. I can do it very inefficiently. So when we are producing something like an airplane, you have to think through and say, how can I change the way I do things so that the impact on the environment is reduced? Then at the end of the story, what do I do with this stuff? Right now there are many airplanes that are getting old, many hundreds of airplanes that are getting old, that are going to be basically trashed. So how can you recover? What do you do with those airplanes? And recently I was reading somewhere, what happens to old airplanes? Any idea?
Museum.
Anybody has an idea what happens to the aluminum from old airplanes? No, they become Coke cans. That's really true. They cannot be used for aircraft purposes again, but they can be used for other purposes. But in this case, we are talking about composites. So composite, what do you do with the composite material after the, the end of life? So you have to think about recycling of that. So for example, some of the innovative technologies. This airplane has become very, very famous for the composite primary structure. Historically, I mentioned back in 1916, airplanes were made with wood and covered with some fabric and so forth. And then they started introducing, and the original airplanes used cables to support, and then the cables turned into struts, and then it was still using wood and so forth. And then slowly morphed into a variety of aluminum alloys. Aluminum alloys is not one thing, there are many different grades of aluminum alloys. But basically we graduated or changed from wood and that type of materials to metals. And this is a huge change now when you're going from metal to composite. This is not the first airplane to introduce composites. In fact, composites have been used in commercial airplanes. Even prior to this, like 777 uses some composites, and even 767 uses some composites. Military aircraft have used composites for quite some time. But this is the first time that a large commercial transport aircraft is using a huge amount of composite material as part of the primary structure. And that introduces some good things. For example, the larger windows are possible because of that. And then again, we have what we call innovative systems. These are more. There are what you see is the outside looks nice, but if you open, or even if for example if you are landing and you look out the window and look at what's happening in the wing, there's all kinds of stuff under there that does not look like very cool aerodynamic shape. All kinds of tubes and various things which are necessary to operate the devices there. Now, if you open up the airplane, there are even more things like that. So there are many systems. So when we talk about innovative systems, it is to make those systems much more efficient and reliable. Aerodynamics I mentioned before. We want to travel with the lowest amount of fuel consumption, but we cannot only depend on the engine to provide that benefit. The airplane itself, the aircraft has to be designed so that it has a better aerodynamic performance, and also as well as a smoother ride that was mentioned before. And then of course the engine technology. Now the engine technology is not something that Boeing works on. We have two engine providers for this aircraft, GE and Rolls-Royce, and basically Boeing tells them, hey, if you want to offer engines for this airplane, this is what we expect it to do, and then they go and develop the necessary technology and the product for it. So this is the picture that sometimes gets confusing. People say, wow, now people are going to stop making airplanes with aluminum, everything is going to become composite. That's not really true. About 50% of this airplane is made of composite material, but then you still have aluminum, titanium, steel, and so forth used. So there's still, half this airplane is still metal. Okay, so don't look only at the outside and conclude that, okay, metals are done. Metals are not done. They're going to be around for a long time. The mentioned modern systems. So this particular airplane has gone to what we call a more electric architecture. So instead of using a lot of tubes filled with hydraulic fluid, there's a lot more usage of motors and then systems that involve electrical type signals, which can be much more effectively used. For example, for maintenance, it talks about E-enable. So it has sensors which can detect, which can track the performance of various parts of the airplane, and then with that you can now take that information, use that information to your advantage, especially if you want to predict when something might fail, or if you know that some airplane that is going to be landing in Mumbai has a problem, I can get my spare part ready so that you don't sit down here and then spend half a day trying to figure out what's wrong with this airplane. So that's what we mean by E-enable. And then this has to do with the open software, has to do with improvements that one needs to make as you get more familiar with the airplane, as technologies improve, as new gadgets come along. For example, when we started building this airplane, there was no such thing called an iPad. But today, all pilots would like to, instead of carrying this big bag that they carry with paper and stuff, they say, hey, why can't you put all that in an iPad? I just want to pull out my iPad and look up my instructions. So technology changes. And if technology changes, we must be able to support them to use that new technology. So that's what the open software architecture and so forth means. It means it is built with those kinds of things in mind. Anticipating changes will come, and when they come, we'll now be able to make the appropriate modifications. The cockpit we refer to as the flight deck. It's all very much more electronic. The old ones that this has been an evolution. This is not the first airplane to do that, but this actually, I don't think I have that picture here, but I have a different picture where it looks quite modern. I mean, when you look at it, it looks almost like something from Star Wars. It doesn't look like an airplane cockpit that you are used to seeing. Again, open architecture is mentioned here, and then commonality between aircraft, commonality between this aircraft and other aircraft that we have, and the open architecture basically says, if technology improves, somebody comes up with a different display system, different gadgets, I can take one out and put another one in, and I'm off and running, ready to go. These are some of the changes on the aerodynamics. Again, the big message here is that the usage of supercomputers and computational methods have been significantly increased on these airplanes compared to our earlier models. And even though we have done, we all have to do any airplane we come up with, there is a fair amount of internal testing done. But actually, if you look at the number of models made, number of hours of internal testing on this airplane, it's actually less than what we have done in the past. So we have increased our dependence, based on our confidence on the analysis method. So supercomputers and computational fluid dynamics have made a big impact. Again, CFD is something that we've been using for the last 30 years. So we are beginning to see the sufficient maturity, sufficient confidence to be able to do things like this, more than what we used to do before. Engines, I mentioned before, GE and Rolls-Royce, they have created new engines for this aircraft. The the second bullet that says no engine bleed. Engine bleed basically used to be the way you would extract some of the compressed air, use it to run various systems. Now, in this case, because the systems are made are electric, you don't need to do that, which basically helps the engine to become more efficient. They are interchangeable at the wing. It's more of a very specific thing to help the airline. But they also use laminar flow nacelles. Laminar flow nacelle technology was originally developed back in the late 80s and has now matured enough to the point where we can actually incorporate that. Again, that's another way to reduce the drag of the airplane. Lots of companies involved. I mentioned before, this is a global project. We don't see the Indian companies listed here again. I saw lots of signs of Eaton on the campus. So Eaton is one of the suppliers, one of the partners with us. You don't see any specific Indian company listed here because they are not the main players. They may be Indian companies. In fact, there are Indian companies, working with some of these, but they are at a lower level. So these are what we would consider as our tier 1 or high-level partners. These are again indicating who are the people manufacturing various components. And again, you see a lot of countries here. Tulsa, Oklahoma is not a country; it's in the United States. Derby, UK. Winnipeg, Canada. Sweden, again, Kansas is in the UK. Japan, Italy. Who else? Australia. So things are coming from various places. Even Toulouse is there. Toulouse is where Airbus is headquartered. So various things, various parts come to are manufactured there and then sent over, and they are actually, so what they manufacture is major sub-assemblies. So they take all the little pieces, put them together into a big component, what we call a sub-assembly, and then those things are loaded up on this airplane that looks like this. In order to transport all these huge things, we created what we call a green lifter. So this is a 747 aircraft modified to have a much bigger, volume, so we can put stuff in there, bring it from Japan and Italy and so forth. So I think there were 2 of them, there may be more than 2 now. So it's a unique airplane built so that we can assemble the 787, and then they kind of come from various places in the world, eventually end up in Seattle, which is the topmost star there, which is where the actual assembly of the airplane takes place. This is the assembly line. Again, how things get assembled. There's a video here, I think I'm going to skip that. Lots of different things that have to get done. And then what you see is once the initial flight test happens, there is a whole bunch of additional tests that the company has to do to convince our friends in the FAA and the European equivalent body to say that this airplane is safe to fly under various conditions. So hot weather, cold weather, rain, snow, sleet, all kinds of things. Takeoff and landing in airports that are located at high altitude. Can it do short hops? How far can it go? Can it go as advertised, or will it run out of fuel somewhere in the middle? So various things have to be shown. And there were 6 aircraft that were actually dedicated for these flight tests. There were something like, I said more than, something like 1,000 flights just to prove all these various things, involving more than 3,000 flight hours. And you basically have to prove things like initial airworthiness, flutter testing. Flutter is a particular phenomena that involves, the interaction between the structure and the aerodynamics. How does the airplane behave near the ground? Does it behave well under crazy weather conditions? And then I'm not sure what the TIA there is. Again, icing is a major concern. Will the aircraft be able to handle adverse weather like icing? And then at the end of all this, we basically get certified. And similarly, the other things, some tests done in a lab, some tests done full scale. We actually build it and do these stress tests to show that the way we have designed it actually is reliable and works. So all that is necessary before we can get permission from the authorities and say, okay, you are now allowed to use this to carry passengers. So that's kind of what happened. There's a lot of technology at various levels are involved in this. Let me show you a video. Noise should become less on the video. Basically, so that's the story of the 787. Now, coming to India, there are many programs that are either just getting started or already in the pipeline. I don't know if you guys have heard about the LCA, the Light Combat Aircraft, that's been in works in India for quite some time now. There is a naval version of that that is being prepared. There is something called a National Civil Aircraft, something like a 70 to 90 seater aircraft that NAL is going to be working on. That they've got permission to start that process recently. There's also an effort on developing a military transport aircraft, a joint project between India and Russia. And then there are many other things in the space arena, in unmanned vehicles, and so forth. So actually, this is an interesting point in time where India has several projects which are being approved and people are working on. And these are some of the organizations who are looking for, I say, good engineers. Defense Research and Development Organization, they are the ones who develop more of the military side of the business, including their unmanned air vehicles and missiles and so forth. National Aerospace Labs, they do a lot of research. They are also the people involved with the National Civil Aircraft Program. HAL does mostly manufacturing. Whenever these things, somebody develops the aircraft like the LCA, eventually it is manufactured by HAL. Indian Space Research Organization has some very interesting plans for the next decade and beyond. In terms of going back to Chandrayaan-2 and interplanetary exploration and so forth. And then of course there are many private companies who are working not so much to build aircraft, but working to support companies like Boeing and Airbus and so forth. So there are many different opportunities that are either already in place or emerging in the Indian marketplace. Now, if you think in terms of opportunities, where can one play? Actually, one can play in the aerospace arena doing a variety of different things. One could be doing research, which would be about how to improve things in the future. Development would be trying to prove that a certain new vehicle, new kind of configuration can be done. Design comes after that. Once I kind of know how this thing looks like, I have to go and do what we call detailed design. And then of course you have to manufacture, which is not trivial by any means in aerospace. There are many materials that are developed in aerospace. Aerospace uses materials very unique to the applications. So there's a lot of work constantly being done in that arena. And then of course there are the operators of the aircraft themselves. Whether it's a military or a civilian platform, they have to be maintained. At the end of the day, they have to be recycled, not just thrown away in a boneyard someplace, but recycled because of the environmental interest. And over the next few decades, there is going to be need for both expertise and leadership. I kind of distinguish between those two because you can be an expert without being a leader. Leadership is more than simply expertise, and you need those kinds of things in various areas. I know most of you are already heading towards a graduate or a postgraduate degree, but you do need people with specialized knowledge, specialized degree programs for more of the research type of activities. But then when you are talking about manufacturing and design and so forth, you don't need PhDs. You need good engineers. And sometimes people actually come and tell me, if you have a PhD, you probably won't make a good engineer. It's not really true, but people sometimes think. What kinds of expertise? These are some of the things that come to my mind. Again, design analysis, manufacturing, and so forth. You need leadership in these areas. You have to be able to think at a systems level. Project management, program management is very, very important in aerospace. And then supply chain management, because of the many, many different entities that contribute to this massive complex systems. Those are in some sense management oriented, but really at the end of the day aircraft and space systems and so forth are really very highly technical engineering products. So we're not talking about somebody who has an arts degree and has an MBA and suddenly can start working. It doesn't work very well. You do need a technical background. You also have a need for various other support services. And if you look at what degree program should I study, it is practically anything. We have in the Boeing company, we have some aerospace engineers, we have lots of mechanical engineers, quite a few in the electronics, avionics area. Metallurgy, material science is a big thing. Manufacturing, of course. Then we also have chemical engineers, mathematicians. We even have historians. I didn't put history here. We even have people with history degrees who work in Boeing. So, if you want to work in aerospace, you could have a variety of backgrounds. The real thing you need to have a passion for the industry, and you need to develop some skill that is valid. I mean, the degree programs are okay. It's nice to have a degree, but just because somebody has a degree doesn't mean they are educated. You understand what I'm saying? You can have a degree. So what we need is people who have education more than degree. And I know personally people in Boeing, and I'm sure similarly in places like HAL, who just have a bachelor's degree. But the amount of knowledge they have is 10 times more than this PhD who walked in the door 5 years ago. Okay, so degrees are nice to have. They open the door. Maybe somebody will call you for an interview. But really, if you want to succeed in an education, and an education is not a 4-year process. Education is a lifetime process. Okay? If I stopped learning when I graduated, I wouldn't be standing here in front of you. Okay? So, somebody told you, hey, just work hard for 4 years, get that piece of paper, and you'll be all set for life. They lie to you. Okay? If you really want to succeed, you got to keep learning and expanding your horizons as long as you want to be in the business. If you say, okay, I'm going to retire tomorrow, maybe it's okay. But as long as you're not going to be, you don't want to retire or you don't want to get fired, you better keep learning. Okay? Alright, this is my last chart. Again, my point is, this is not a discipline, so I do have degrees in aerospace. I have 3 degrees in aerospace, but not necessary to have a degree in aerospace to be in this industry. This really means bringing a lot of different things together. They are complex products, which means you need, if you want to be effective, you must not only be an expert in one area, but you must know things around that area. That's what makes you special. Again, India also has many things around emerging as opportunities, and depending on your interest, depending on what makes you tick, there are many ways to participate. And again, the bottom line is, if you provide value, you will have a job, you will prosper. If you simply say, I'm an expert, everybody should recognize me, it doesn't happen automatically. You have to provide value. Okay? That's it, guys. Thank you for hanging in there.